Greetings, good evening. Thank you for the welcome. Apologies, I am an Englishman and I only speak English, so you're stuck with the English delivery today. That's the laziness of an English person. So it's a great privilege to be here. Just a few seconds on where I've come from. I spent 22 years heading up the broadcast technology team at British Telecom, which is it's the Telefonica of the UK, if you like. I then was tempted to the dark side of Vendorland in 2010 and spent 13 years with Nevion, which then became part of the Sony group. And then just under 2 years ago, I was tempted over to join Appear, which is also another Norwegian headquartered broadcast technology group, and I'll give you just a little taste about what we do. As well as my involvement as CTO of Appear, I'm actually very involved in a lot of the broadcast standards organisation, so I'm very passionate about open standards, very passionate about bringing the industry together, and I'm going to talk to you a little bit about that as we go through today. As has already been said, I did have this slide normally says, please shout out questions, but we're tight on time, so save your questions unless I'm really quick. Save your questions until we have drinks afterwards. That will be really good. So just so you know where I come from, the very east coast here, this is East Anglia on the east of the UK. I'm about 1 kilometre from the sea where I live, and it's a nice place to live. And I worked out 1,350 kilometres to come here, so which is 4.5 milliseconds with the speed of light, or in fibre, that's 6.75 milliseconds I worked out. So who else has come anywhere further than Madrid? Has anyone else come from further away? Barcelona, okay, we've got Barcelona. Can anyone outdo Barcelona on distance? London, okay, very good. Okay, anyway, nice to have you with us wherever you are. The other really important thing I need to know is how many other tea drinkers there are. So hands up if you're a tea drinker rather than a coffee drinker. I see 1, 2, 3, 4, 5 hands. Oh, coffee, put your hands up. Wow, okay, I feel really overwhelmed there. Just one more little plug here. I do a fairly regular podcast called Time for Tea with Andy, back to the tea theme. So if you want to check that out on any of the streaming platforms, you can do that. And just a very quick bit, just one slide about what we do. We make infrastructure to connect broadcast, business to business broadcast connectivity, largely for events and sports and facilities. And this is our flagship product, and lots of things that we embedded within that on this slide, but I can talk to you more about that afterwards if you'd like. But let's move on to the meat of what I want to talk to you about. First of all, live production. What is it about? What do people that do live production want to do? And I can summarize it in 3 very short bullet points. Generally, they want to lower the cost of their operation. That's a continual requirement. They want to increase the production value. They want to make more compelling content, and they want flexibility in the way they do it. Those seem to be summarizing, those 3 points seem to summarize everything. And my little circle underneath there, that's really all about personalization, because one of the ways of upping the production value that we're seeing, which is putting quite a lot of demands on the whole live production workflow, is increased personalization of the content that's being made. So that's if you like, the headline. In terms of the workflow we're talking about, so just going back to what Appear's doing, it's really all of this interconnection piece between the elements here. But we start with an acquisition site. We actually may be co-located, and I'll come to that in a minute. We have the production processing, the actual making of the program and the content, and then we actually have the consumption part. So that's the workflow, and I'm going to be describing different parts of that chain as we go through. Back in lockdown, the DPP, the Digital Production Partnership, had a bit of a brainstorm session online to talk about the different ways people are doing production. Now, if Spain was anything like the UK was, suddenly we had to reinvent ways of doing production when people aren't allowed to be together. And that really accelerated from this traditional model here, where you've got the acquisition, the production equipment and the controllers all co-located. That really changed, because typically a lot of the controllers were sitting in their garage or their dining room. So quite often the kit was still there, but all of these different models of the way you connect acquisition, processing and storage and the controllers are now very, very valid. And the one at the bottom, which I'm hoping you can see, is cloud or compute function, where you're actually doing the actual processing and storage in the cloud. So those are all kind of relevant because they play into what I call location agnostic live production. And there are several reasons why this is beneficial. This is transformational. We've been doing IP video for 25 years now, and a lot of that was initially wide area connectivity, and then facilities became more and more IP connected, starting maybe 10 years ago. And really what's happened now is those things have joined up. So now we are actually able to have back end-to-end IP connectivity that subsumes the whole chain. And that actually gives immense flexibility. It means that the resources can be shared. It means people can actually be doing a lot of the production work from a central location, far less traveling, a much more sustainable approach. You need to ship far less equipment if actually all you're shipping to the location is the cameras and the microphones and a small amount of infrastructure to pull them back. So all of these have advantages. There's also some unseen ones, like I didn't think about until last year at NAB when I was talking to someone, like accessibility. You know, the truck in the back in the car park at a sports event is not very accessible, but if you've got a purpose-made facility centralized, then people that have accessibility requirements are able to actually be part of that. And also, people working at a base can maybe do 2 or 3 programs a day, whereas if you're traveling, you can do maybe 1 program every 2 or 3 days. So there's a whole workflow transformational gain there, and all the equipment can be shared. So quite a lot of expensive broadcast capability can be actually shared. Another trend that the broadcast industry is going through is what I call the bespoke to the generic. So hands up if you have used the BNC or the XLR connector in your industry, in your world. Quite a few people. Okay, you know, that will in another generation be a thing of the past, because more and more things are becoming IP Ethernet interfaced. So then, you know, in my dreams, you know, all of those VM700s with the video eye trying to look at the performance of the physical layer, we don't have to worry about the physical layer of connectivity anymore, because we're abstracted from that as we carry things over industry IT standard infrastructure. And IT infrastructure is a market that's orders of magnitude bigger than the broadcast market. So if we can leverage the IT market for everything we do in broadcast, or most of the things we do in broadcast, there's massive synergies there and cost savings. And this is a real trend we're on. Virtualization, moving from specific products that do specific things to compute that's actually running that. Dematerialization, my friend from CBC in Canada, he coined this phrase when he was at the EBU a few years ago, Felix Poulon, which basically means the stuff I'm running isn't even with me, it's somewhere else. I don't even have it in my facility. And networking, 10 years ago, all connectivity for broadcast was pristine, very costly, private leased lines from service providers. What we now have here is public internet connectivity, which is actually much, much better than it used to be and can be used with the right tools. We have 5G, we have low Earth orbit satellites. All of these can actually provide pretty good connectivity, which we can use, which cost orders of magnitude less than leased lines. So this is transforming things, and it's also making a lot of things viable. As we move to this virtual world, there are a few things you're always going to need. It's the bits that interface to the human beings. So we need the cameras, we need the microphones. A lot of people still like a tactile surface to push rather than button clicking on a mouse. And we still need the speakers and the monitors to actually give it back to us at the far end. But apart from that, we're actually, you know, virtualizing a lot of other things. Cost viability. A lot of this transformation is making the cost of doing productions relatively much cheaper. So actually we can start to do lower league sports with multi-camera productions, which would have not been cost effective a few years ago. So we're democratizing, we're enabling far more content to be created because of that. Video compression. Those of you that have been in the industry and will have seen this famous triangle: quality, latency, and bandwidth. Why do we do compression? If we go back 90 years to the advent of video, the first video compression that was done was something called interlace. The idea was you send half the picture now, and then you send a field later half the other picture. Fast forward 90 years, it's a right pain in the butt, and we're still living with interlace now, which we shouldn't be. But basically, everything has been thinking about how we reduce the bandwidth. So we have various compression tools now, which we use to compress the bandwidth. Now, that requirement to compress is becoming less and less because bandwidth is becoming more and more. Even at home now, I've got 1 gigabit per second, which I can still remember dialing up with 28 kilobaud, to do my emails in the early days. So that's transformational. But we've got these technologies. We've got what I call temporal compression, HEVC, AVC, and then what I call mezzanine compression, which is far less aggressive, but much quicker and potentially higher quality with the JPEG XS and JPEG 2000. Compression is still very important, sometimes for storage. Compression is also very important because if we want to do more and more of this remote production where the acquisition site is remote from the production site, we may have 6, 12, 20 cameras we need to pull back, and each of them, we may need to have some compression on to make it fit within the available bandwidth. But now, with a gigabit circuit, you can actually do quite a serious remote production with the tools that we've got around it. So there's some legacy in the way we think about video. This is the way video was done, basically right from the beginning. Originally, actually, if you look at the very early video, instead of the raster scanning horizontally, it actually scanned vertically. The very first video tests were vertical scans. But now we have this, and basically this concept of scanning, transporting one line, then the next, and then having a bit of a wait, then doing the same thing, has actually been perpetuated through digital, and as we've moved to IP, including with 2110. 2110 has something we call gapped, which actually is modeling the flyback time of the CRT scanner, and we've perpetuated that to now. But we are on the cusp this year, I think, of a transformation in the way video is going to be carried and manipulated. So this is akin to that, what I call the hose pipe. The last 90 years has been like a hose pipe. It's a continual stream of water. And we have just pushed out one sample after another, or, in the analog days before that, the actual analog waveforms. And then in the packet world, packet. And we've had a constant expectation of the time it takes to send one frame of data, the next one, and that aligns with that time as it exists. I talked about the changes in connectivity. So this is the expensive leased line stuff that you would typically buy as a high tier broadcaster. There's then connectivity in what I call in the middle. There are other cloud providers available. I'm using AWS purely as an example, but they have something called Direct Connect. And that provides data connectivity. Now, the thing you may not realize is this connectivity is not as pristine as this. This connectivity on the left was pretty well perfect, apart from when it goes down. But when it's operating, it's pretty well perfect. These other technologies, the fiber to the premises, public internet connectivity, and I have to say, including things like cloud connecting, are lossy. They inherently have packet loss in the way they work because of contention, because of arbitration, etc. So we've changed. So we actually need to use different tools if we're using those types of connectivity to actually give us integrity. Looking at public internet connectivity again, so the cost is a massive gain. I talked to some people, I think at the Commonwealth Games in London, in Birmingham a couple of summers ago, and they were doing some broadcasts for the BBC, and I think they were talking about the cost of the connectivity because they were using public internet connectivity for that. It was 1/100th of the price of the equivalent leased line. It is, however, less reliable. Generally, there's less bandwidth available, and potentially it's less secure. So there are challenges. Also, generally, there's more latency because you have to buffer to protect, and we'll come to that in a minute, more jitter. But the reach is phenomenal, and the flexibility is phenomenal. So this is why the adoption has been so high. So what do we need to do if we're not paying for those really expensive leased lines to actually connect our live production? We've actually got 3 fundamental technologies we can do to what I call healing the signal. On the left, we have what I call RTP merge. This is spatial diversity. You send the same stuff via this route, and then your end equipment merges it. So as long as you haven't lost the same data on both legs, if you do this seamless merge, then you're good and you can work with that technology. We have error correction, which again is something that's been about ever since the advent of digital. And basically what that means is you actually are able to correct for some of the lost data that you incur. And then we've got something that we're using more and more now, which is called ARQ. It's basically an inverse handshaking. TCP, which is what we mostly use for most of the data world that we live in, is a positive handshake. You handshake every transaction. The ARQ technology, which we're using for broadcast, is an overlay on UDP, which is a fire and forget packet technology. And what we do is we only send a request for a new packet if we've lost it. So we track what we're losing and we send a request. And this technology is actually really useful as a way of making those lossy but much cheaper network connectivities work. But there is a price to pay, because to do this, all you've got to do is align the shortest route to the longest route, and you can merge the packets. There is no latency cost there, really. FEC has some latency cost because you've got to store some data. But this, you've actually got to go all the way back to the source, say, send me that packet again, and come back again. So as a minimum, you've got one round trip. And if you want to make it recursive, you've got more than that. So if you've got a route that's 10, 20, 30 milliseconds, you've got that again to allow you to do the integrity. But this tool, especially a de facto standard called SRT, has really taken the industry, and we're now using it not only for distribution, but in live production as well. Okay, we're over halfway now. So, favorite ice cream. I'm going to tell you I have 2 favorites, salted caramel and ginger. Anyone else want to tell me a favorite ice cream? No one eats ice cream here. Everyone. Any favorite flavor ice cream? Lemon. Thank you. Any more? Chocolate. Thank you. We'll take one more. Strawberry. Okay, that's fine. I just wanted to make sure you're awake. On to time. Timing is really important in broadcast, and I'm just going to deal for 5 minutes with 1 or 2 nuances of this. Several famous people in history have had a few things to say about time. I just want to talk about timing in broadcast. The very, very early times of broadcast actually had a lot of latency in them. We think we're concerned about latency in broadcast now. The very first, when John Logie Baird did his very first live television broadcast, his camera couldn't work in a lit studio. It was a flying dot scanner. So they had to have a telecine system. So they had a film camera, they had film that was developed live and went into a scanner. So the latency of the actual broadcast was 42 seconds, because that's the quickest they could develop the film and then scan it for the transmission. So if we think we've got problems with buffering nowadays, just think back to 1936, because that was quite long. So there is, in my mind, only one non-negotiable latency. I mentioned it at the beginning when I talked about my 6.75 milliseconds from home on the speed of light in fibre, and that is the speed of light in fibre. That's the only non-negotiable. There's lots of other things we do with time in terms of buffering that are not necessarily always necessary, and one of my passions is making sure we minimise them. So in terms of time alignment, when did time really start mattering? It was the railways. That's when relative timing between places actually was the first thing that really was important. And what is the time? If anyone's as old as I am, you'll remember the speaking clock. You could ring a phone number to actually find out what the time was. And we had the pips on the radio, and we still have them in the UK on Radio 4 that tell us the time. But the thing is, that time is now not very accurate, because I now actually listen to all my radio at home on Sonos units that are streaming. So actually, when I hear that beep for the top of the hour, it's probably actually 10 or 12 seconds after. And I used to be really anxious about that, but actually I've learned to live with it. It's okay. And timing does really matter for some things, like betting sports. People are really, really worried about the time, because if someone can actually find out something earlier than the people that are making the decisions, then there's lots of stuff. Obviously, when you watch things on any streaming channel, you have a lot of buffering happening. The system is designed to buffer to make your experience better. But as we're going back to live production, what is acceptable latency in production? So we've got this chain, and the most important bits, as you'll probably have seen if you see people doing interviews with satellite connectivity, as they have been for the last 30 years, there is a certain time. It takes probably a second for that, or maybe a second and a half, and you see the reporter waiting there. And those guys are trained to cope with being professional whilst that comes through. So there are some elements here, especially talk back into people's ears in the studio is really, really time critical. If you want to hear back something that's happening, then that needs to be 5 milliseconds. You can't go more than that. So there's some really critical times. There are other things where the time itself is not so important, but the regularity of the time is important. How am I doing time-wise, talking of time?
20 minutes.
I've done 20. Okay, I'm going to whistle through this last bit then. Time alignment is therefore really, really important. What we do now in production is we have the audio and video on separate routes, and we need to actually align them when we're actually bringing them in. So that's a really important element. The last thing I want to just focus on for a couple of minutes is live production evolution. So I've talked about this hose pipe. We're now moving to compute to do live production. That compute is non-linear. Computers don't do time linear stuff. They take a bunch of data, they do the math, and they push it out. And what we've been trying to do, as we started to use computer technology here, is try and force computers to do linear time. And they don't like it, and it's very inefficient. So we're actually trying to work on some standards this year for the industry to actually do what I call asynchronous time handoff. We still need to know what time things were acquired, so what timestamp that video frame or that audio sample was arrived at, but the processing can be asynchronous and needs to be asynchronous for compute to work well. So that's a really, really important element. I'm going to jump through a couple of these. These are some of the bodies that are involved in doing some work on this time, and this compute to compute or cloud to cloud work is the stuff that's happening now and is really, really important. We did a first demo of this in NAB at VidTrans 2 weeks ago, the GCCG API. I can talk to you more about that later. This is the first demo of asynchronous compute handoff. Really exciting, because as we converge in compute, a lot of those other tools, that the AI tools, the highlights creation, all of those, because we're actually doing the live production within compute, all of those tools can nicely nest in and be part of the system. And 2 more slides to go. This is kind of the software production workflow chain that I'm working on with some of my team. This is what happens, if you like, coming into the production system, the different tools we need, the manipulation we need to do. Then in the green here, we've got what I call the dynamic elements, the actual vision switcher, the audio mixer, the replay server, the graphics engines. And then we're coming back out of our software ecosystem and heading towards the end user. So I think we've got like a double hybrid future here. We still have the need for stuff on the ground to interface. We have the need for compute, and that compute is going to be hosted on-prem because of cost-effective 24/7 operation, and in the public cloud to allow us to burst. That's the really important thing. My last but one slide, security. Security gets overlooked a lot in broadcast. The great thing is, the IT industry does security pretty well. They have to. So all we need to do, and I use words all in quotes, is leverage the tools and the techniques the IT industry are doing and make sure we apply them to the way we do control and data flows within broadcast. And that comes up, and that will sort it out. So this is just my summary slide, coming back to this picture. A whistle-stop journey on some of the elements on transporting, manipulating video. Very happy to unpack that over a drink later on. And it finally leaves me to invite you, if you're ever in the UK, to come for a nice cup of tea. So send me a LinkedIn message or reach me on my cell phone. Thank you for your time.